Hello everyone, it's really good to see you here. So today we are going to solve a GFG problem which is based on graph, and it is detect cycle in an undirected graph. So we have given an undirected graph with V vertices and E edges, and what we have to do is we have to check whether this undirected graph contains a cycle or not. So let's dive into its approach part. So we are going to use DFS to solve this problem. So we are going to traverse the graph using DFS traversal technique. So for this, we have to firstly have a visited array which is initialized 0 initially. So all the elements of size V, which is number of vertex inside a graph, are marked as 0. Now what we do to have a count of parent, to have a count of parent of that particular vertex, we take an integer p which is going to be initialized as -1 initially. So let's suppose we are going to start from this node. So what happens is that the parent of this particular node is -1 as of now. Now this node going to call recursively using DFS for this node. So now the parent become 1. So the parent of 2, vertex 2 is 1, right? So we have 1 here. Now what happens is that when 2 calls recursively to 3 using DFS, then we got, so here after like each time we are visiting a node, we are marking it as 1. So 1, 2 and 3 we marked it as 1. So once 2 calls DFS at vertex once DFS at vertex 3, we got a parent of this particular 3 vertex as 2. Now what happened is that this vertex 3 calls DFS for the vertex 4. So 4 marked as visited, and then the parent of 4 would be 3. So this parent value got updated each time. Now when this 4 recursively calls for its child node, then or its connected node, then what happens is that you can see that in visited array it's already visited. So what we can now check, that if it is already visited, that means we have to check that if the parent, let's suppose 4 is the vertex, and if we call the DFS for 2, then the parent would be 3 and the node would be 2. So here 2 is not equals to 3, right? That is 4 is a node. Let's suppose 4 is a vertex which calls DFS for the vertex 2, and what happened is that this 2 is already visited, right? So we are going to check the next condition. So we check that if this particular node, if it is not equal to parent, that means there is going to be a cycle. So here in this case 2 is not equal to 3, right? So parent is 3, parent of 4 is 3, but 2 is some other vertex which is not equals to the parent vertex. That's why in this case we can clearly see that there is a cycle. So here this is a cycle. So what we do, we just return 1 from the loop, and this is how we are going to approach this problem. So here why we are saying this is that since this is an undirected graph, so let's suppose if 4 is connected to 3, then what happens is that if it is calling to another vertex, or if it's calling to a DFS call for another vertex 2, then what happens is that, let's suppose here you can see that 4, like 2 is already visited, already marked visited. Now if it is already marked visited, then that means that this vertex has called somewhere, like this vertex has somewhere called before in our DFS function, right? So if this vertex 4 has no cycle, then what happens is that when it is going to call uh, when it is going to make DFS call, then what happens is that this DFS call vertex should be equals to the parent. That is, if the node is not if the node is already visited, so let's suppose this node, let's suppose 3 is already visited. Here let's suppose there is no connection. Then what happens is that when it's going to make DFS call, then this 3 node would be going to call, right? And 3 is already visited, and it is already equals to the parent of the vertex 4. That means in this case cycle is not possible. But if the vertex is already visited, and if the vertex is not equals to the parent, then we can say that there is possibly a cycle, and definitely a cycle actually. So this is how we are going to approach this problem. So firstly, we have a bool DFS which has taken the graph or the adjacency list and the visited array. P is representing the parent and S is basically the starting index for the DFS call. Then firstly we mark visited of index S as 1, and then we just traverse throughout all the nodes of adjacent, all the nodes of a vertex S. Let's suppose x is representing that. Then if the visited x is not visited yet, then we marked it visited, and then we recursively call DFS for that particular vertex. Now in this case the parent become the source vertex or from where it is connected, and we check that if DFS call returns 1, that means there is a cycle. Else what we do, which is in our example case, that our visited x or visited array for that particular x index is already 1. That means if it is already 1, so it should have to be equal to its parent. But if it is not equal to its parent, then we simply say that there is a cycle and we return 1. If these are all not possible cases, then simply that the graph didn't have any cycle, so we return 0. So here bool visited of size v plus 1, and initially parent p is minus 1, because for the starting vertex there is no parent, because it is the parent of all the vertex, right? So firstly we make all the visited index I as 0, and then we are going to call that if that particular visited I is not visited yet, then we call DFS function for that particular vertex, and if it is returning 1, that means if it is a containing cycle, then the answer should be 1, else the answer should be 0. So let's try to submit this up. So yes, this is the approach to solve the problem, detect cycle in an undirected graph. And if you want to access the code, then you can check the GitHub link given in the description. And before going, just do like, share and subscribe to this channel. And this is it. Thanks for watching.